Okay, we've gone to 2.4 here, guys. So in 2.4, we're going to be doing some more proofs. What we've done so far is, given that lines are parallel, we want to prove something knowing that. Because again, even when our lines aren't parallel, like again, this is parallel, right? Not parallel, yeah. Even when lines aren't parallel, we can still talk about corresponding angles and alternate interior. We can still talk about those. But the special relationships where some of them are congruent and some of them add to 180 only apply when lines are parallel. And this is kind of like a if this, then that, and vice versa sort of thing. So what we're looking at today is going in reverse. What we're going to do is prove that a line is parallel if one of those special relationships exists. So what we do is we call these, if you notice, you're looking in your 2.4 notes, all of these are called our converse theorems. We haven't talked about converse before. We used to in the past talk about converse, inverse, contrapositive. Don't worry about that. What you need to know, make a little note here, is converse. Think about that as going in reverse. So write that on your notes. Converse is going in reverse. Or switching things up. Yeah. So in 2.3, what we started off by saying was the lines are parallel. And again, you can see that here. In 2.3, it said we have parallel lines. That was the first thing they said. There are parallel lines. Now notice in 2.4, that's what comes second. They say if this thing is true, then the lines are parallel. So again, if I'm trying to go in reverse, if instead I'm trying to say, hey, yes, I want to prove that these lines are parallel, we use what's called the Converse Theorem, which again means going in reverse. But it's still basic same idea. If corresponding angles are congruent, then yeah, those lines are going to be parallel. If alternate interior angles are congruent, then yeah, the lines are going to be parallel. So forth and so on. Yeah, consecutive interiors add to 180, sweet. The lines are parallel. Once more, the only difference here is that before we started with the lines are parallel, and now we're ending with the lines are parallel, and that's why we use what's called the Converse Theorem, going in reverse. So to start off with, we're going to look at example 1 in your notes packet, just kind of, again, talking this through, not formally yet. We're not writing a proof. You're just talking it through. So it says, can you prove lines P and Q are parallel? You cannot just say, yeah, they look parallel. No. What we are told is this angle is 62 and this angle is 62. So the thinking you have to have is, what's the name of the relationship between those angles? And do I have the correct matching relationship that should go with them? So to start off with, that doesn't make any sense. Tell me, what is the name of this relationship here between these two angles? Corresponding, consecutive exterior, what are they? These are alternate interior angles. Alternate interior angles. Now, look to your notes. You can also look back to the front page here. If the lines are parallel, what should alternate interior angles do? Should they be equal or do they add to 180? They should be equal, congruent, right? That's what equal means. That's what congruent means. So, are these angles equal? Yes. So what that means is, yes, P is parallel to Q because these are equal. Say instead I had this problem, that this said 62 and this said 65. Now, even though they are still alternate interior angles, those are still the positions of alternate interior, they aren't equal. So that means actually P and Q are not going to be parallel. Since the relationship applied here, yes, they're alternate interior, yes, they are congruent, they are going to be parallel. So looking at the next one, same thing. You're going to start off with figuring out what is the name of this relationship between our two given angles. We want to see what the relationship should be for those and see if it actually is true. So start off with saying, what is the name of the relationship between these two angles? These are consecutive because they are on the same side of our transversal, same side of the bridge. Interior because they're inside the river. So look to your notes again. If these lines are parallel, what should consecutive interior angles do? Are they congruent or do they add to 180? They should add to 180. Now we need to double check and make sure that is true because I can't quite see yet. I mean, I can do the math very quickly in my head, but let's do a check here. Do these two angles add to 180? Do it real quick, see if they do. Well, I got 123 plus 57. I can go to my calculator here, but I'm pretty sure it does equal 180. Yes, it does. This equals 180. So what that means is because this is true, we can say yes. P is parallel to Q. Now again, say this said like 80 degrees. Yes, these are still consecutive interior angles. However, because these would not add to 180, what that would mean is then no, P and Q aren't parallel. So that'll be part of the assignment, is checking to make sure just kind of informally, hey, given this information, can I know if these lines are parallel? I'm going to have you guys do two more very quick proofs here that are not in the packet. So just wherever you have space, you might want to take out a different piece of paper. We're going to do two quick two-step proofs so you can get a little taste of the formal proofs we'll be doing in class. So here is our given statement. We're given that angle 1 is congruent to angle 2. And hey, look again, we're trying to prove that the lines are parallel. If you are trying to prove lines parallel, that means we're going to be using a converse theorem. Because again, this is reversed from what we normally do. Normally, we start with the lines are parallel and we go from there. Here, since I'm trying to prove lines are parallel, a converse theorem is going to pop up. But we know our very first reason in this proof because we are smart people. What is our very first reason in any single proof? It is given, right? They are giving that to us, that angle 1 is congruent to angle 2. Now, immediately, this is enough to show that these two lines are parallel, that M is parallel to N, because 1 and 2 have a special relationship that creates congruent angles. What is the name of the relationship between angle 1 and angle 2? These are alternate interior angles, and they are equal, which is what we want. We want alternate interior angles to be equal. Sometimes they're not, but we want that. Now, my reason is just not alternate interior. It's alternate interior converse, because now we are saying, yes, we're going in reverse. We know they are equal, so the lines are parallel. We call that the converse theorem. If I was going the way we were before, yeah, we could just say alternate interior. But if I want to prove lines are parallel, we use the converse theorem. And that's it. That's the whole proof. So try this one more time. It's going to work very similarly. Again, you want to always look at what angles they have told you here. They say 3 and 5 add to 180. You want to see what's the name of the relationship. And again, because our end goal is to prove lines are parallel, we will use a converse theorem. So fill in your two reasons, see if you can get it. Well, the first reason is always given, super easy. And immediately, that is enough to prove these lines are parallel because these have a special relationship, which is consecutive interior. Consecutive interior. But again, because my goal was to prove the lines are parallel, this is consecutive interior converse theorem. Be careful on the assignments. They're going to try and trick you. When you have your little drop-down menus, one of the options will just be consecutive interior. And then one will be consecutive interior converse. So be very careful. It's going to be some easy tripping up there if we're not paying attention to what we really need.